Friends, I really hope that you are doing great. Welcome to today's class. It's our 9th lesson on the topic formula and variation. Remember, in our previous classes we did look at the types of variation, whereby we discussed the direct variation and also inverse variation. So in our today's class we are going to look at the third type of variation, which is called the partial variation. Now the first thing that we are going to start with are the key terms that usually identifies this type of variation. So the key terms that identifies this type of variation, this variation are so these are the key terms that will always identify this type of variation. One, we have the word partly. Should you see the word partly in a given question, it means you are dealing with a type of variation which is called partial variation. The other key term that you should look for is the word partially. They can sometimes use the word partially. So you can be told that a certain quantity is partly constant or partially varies as another given term. So those are the key terms that you need to look for. Then the other thing which is unique about this type of variation is that it takes the form. So the equation takes the form. So it takes the form that is y is equals to kx. Y is equals to kx. Then of course plus c, of course, where c is a constant. That is where k and c are simply constants. K and c are constants. These ones are constants. So these are case scenario whereby you can be told that, for example, a quantity y is partly constant and partly varies as another quantity x. So that the k and c would represent the constants of that particular variation. Then a partial variation can also take the form y is equals to kx, that is kx plus c, maybe w, in this case, whereby the x and w are the variables, whereas k and c are the constants in this particular case. Then in this type of variation, the terms are usually added, or the terms are separated. They are separated. We usually separate the term. The terms are separated by a positive. The terms are separated by a positive. For example, you can see in the first case we are having a plus, which is separating a variable x, then of course with a constant. Then in the second case we are having two variables, that is x and w, whereas k and c are constants which are being separated with a positive sign. So that is how we identify a partial variation in a given question. So maybe to understand better, we can look at an example so that we can understand what we mean by a partial variation. So this is a question which was tested in Kcse 202, paper 1, question number 14. It reads that a quantity p is partly constant. So the word partly simply means that you are dealing with partial variation, and partly varies as. So I'm going to take this particular quantity p. I'm told that this particular quantity p is partly constant. So this particular quantity is partly constant. So we have this quantity, it is partly constant. So that means p will be directly proportional to a given constant. So this quantity is partly constant, and the same quantity and partly varies inversely as another quantity q. So we also have the quantity p, which is partly inverse. Remember, inverse is usually represented by 1 divided by that particular quantity. So the quantity is partly constant and partly varies inversely as another quantity q. Then remember that in variation, whenever we want to do away with the variation simple or the proportionality simple, we usually introduce equal signs with a constant. So in this case, simply we'll talk of this particular quantity P. So we are told that P is, so I'm going to introduce equal sign, then I'll let this particular constant to be actually K. So it is partly constant. Then also for this case, it means that the quantity P will actually be equal to, so remember Q is also a variable, so P and Q are variables. So when I eliminate this particular proportionality simple, I'll introduce equal sign with, I'll let another constant to be maybe C, so that I'll have C multiplying with 1 over Q. So that I'll be talking of P actually being equal to C multiplied by 1, I'll simply get C divided by Q. Then remember that in this case, I'm taking where that is K and C, where K and C are simply constants, where K and C are constants. So these are constants of the variation, or the constants of the proportionality. So remember, we have said that in partial variation, we usually separate the terms with a positive. Therefore, I'm going to combine this equation, P is equals to K. Then I also combine the second equation, P is equals to C over Q. Then, of course, I'm going to add the 2. So when we combine the two equations, we are going to have our equation being equal to P being equal to. So the first equation, we are having K, because we are told that P is partly constant. And the same P is also partly varies inversely as Q. So inversely as Q will be represented by C divided by Q. So I'll have K, then plus C, then of course divided by Q. Of course, where K and C are constant. So P is partly constant, and so and is represented by the addition sign, partly inversely as Q. So inverse is 1 over Q, then of course C represents the constant. Then from there, I'm going to substitute the given values, so that I can use them to get the constants, that is C and K. So I'm told that P is 10 when Q is 1.5. So I'm going to substitute. So I'm going to have P, which is equals to 10. So I'll have 10 being equal to, then I have the constant K. Then of course I'm going to add the constant C, then divided by the variable Q. So I'm told that P is 10 when Q is 1.5. So I'm going to divide by 1.5. So of course 1.5 is common, so I'm going to multiply through by 1.5, which is the LCM, so that I can do away with the fraction. So I'll multiply this equation by the LCM, which is 1.5. I also multiply this term by 1.5. I also multiply this term by 1.5, so that I can do away with the fraction. Now, if you take 10 multiplied by 1.5, you're going to get positive 15. So this will give me 15 being equal to, then of course 1.5 times K, I'm simply going to get 1.5 K. Then of course plus 1.5 and 1.5 will actually cancel out, so that I remain with C. So this will be my first equation. So this one will be equation Roman 1. Then if I want to get the second equation, I'm simply going to substitute the second conditions that I'm given for this particular equation. So we are also given other conditions that we are going to substitute in the same equation, whereby we are told that when P is 20, Q is 1.25. Therefore, I'm going to substitute. P is 20, so I'm going to substitute in the same equation. So this one will be P is 20, so the equation will be 20 being equal to, then I'm having K, which of course is a constant. Then I'm going to add a C, which is also a constant, then divided by the corresponding value of Q when P is 20 is 1.25. Therefore, divided by 1.25. So of course 1.25 is the LCM, so I'm going to multiply through the LCM so that I can do away with the fraction. So I'll multiply this term by 1.25, which is the LCM. I also multiply these by 1.25. I also multiply the other term by 1.25. Now, if I take 20 multiplied by 1.25, I'm going to get 25. Therefore, I'm going to have on this other side, I'll have 25 being equal to, so k times 1.25, I'll simply get 1.25k, 1.25k, then of course plus 1.25 and 1.25 will cancel out, so I'll simply, I'm going to have c, so this will be my equation Roman 2. Then from there, to find the value of k, remember these equations are simultaneous, so I'm going to use elimination method. So I'll write the second equation and also the first equation. So the second equation is 25 is equals to 1.25k, then of course plus c. Then I also write the second, that is the first equation, which was this equation here, which is 15. 15 is equal to, we have 15 is equals to 1.5k, so this is 1.5k, then of course plus c. So if I want to use the elimination, I'm simply going to subtract these two equations because c is common and therefore will cancel out. So if you take 25 minus 15, we are going to get 10. So this will be 10 is equals to 1.25, then minus 1.5. We are going to get negative, so this will give me negative 0.25, then of course k. Then c minus c, you are simply going to get 0. So I'll divide through by negative 0.25. I also divide through by negative 0.25 so that I can get the value of k. So 0.25 will cancel out, so that means the value of k will actually be equal to, so I'll have 10 divided by negative 0.25. So this is going to give me negative 40. So the value of k is negative 40. Then I'm also going to get the other constant, which was c, by substituting in my equation Roman 1. So I'm simply going to say that substituting k is equals to negative 40 in equation Roman 1, I'm going to get the following. So equation Roman 1 was 15 is equals to 1.5k, then of course plus c. So if I substitute, I'm going to have 15 being equal to, so I have 1.5 then into k, so the value of k is actually negative 40. Then of course I'm going to add c. Then let me separate my working with a line here. So I'm going to get the following. So this will be 15 being equal to, so 15 is equals to, so if I take 1.5, then I multiply with negative 40, I'm going to get negative 60. So this one is equals to negative 60, then of course plus the constant c. So that means the value of c will be given by 15, then of course plus 60. So if I take 15 plus 60, I'm going to get 75. Therefore the value of c is equal to 75. So this one simply means that the equation connecting, that is p and q, will be given by, so remember the original equation was this one here, it was p, the equation was p is equals to k, then of course plus c divided by q. So if I substitute the constants that I've worked out, I'm going to get my equation being equal to p is equals to k. My value of k is actually negative 40, so this is negative 40. Then of course I'm going to add the value of c, which is 75, so this is 75, then of course divided by q. So this is the equation connecting p and q. So they wanted me to find the value of p when q is 0.5. So the value of p will be given by, so I'll have negative 40, so negative 40, then plus 75, then of course divided by Q. So I'm told to find P when Q is 0.5, so this would be divided by 0.5. So if I feed this on my calculator, if I take -40, then of course plus 75, then of course divided by 0.5, I'm going to get 110. So it means that when the value of Q is 0.5, the value of P will be 110. Then we look at our second example, which is also a past Kcse question tested in 209 paper 2, question number 3, which reads that the mass, we are told the mass of a wire M grams is partly constant. So we are having the mass M, which is partly constant. So this is partly constant. So this one simply means that I'm going to have M being equal to, let the constant to be K. Then, and partly varies as the square of its thickness T. So the same mass M partly varies as the square of its thickness T. So this one is partly varies as the square of its thickness T. So that means M will actually be equal to, let the other constant to be C, T squared. So because of the word partly, it means that we are dealing with partial variation. Therefore, we need to separate the two terms using a positive or an addition sign. So it means the equation connecting these two will be M is equals to, it is partly constant, so the constant is K. So M is partly constant and partly varies as the square of its thickness T. So I'm going to add, so I'm simply taking K, then I'm going to add CT squared. So it partly varies as the square of its thickness T. Now we are told that when T is 2 millimeters, M is 40. Therefore I'm going to substitute. So M is 40. So I'm going to have 40 grams being equal to the constant K, then plus C into T. The value of T is 2. So this will be 2, because it is T squared, I'm going to have 2 squared. So I'm going to get 40 being equal to K. Then of course I'm going to add 2 squared, I'll get 4. So this will be 4C. So this is my first equation. Then to get the second equation, I'll substitute the second conditions that I'm given. I'm told that T is 3 millimeters when M is 65 grams. So I'm going to substitute in this equation, which is M is equals to K, then of course plus CT squared. So I'm told that T is 3 when M is 65. So I'll have 65 being equal to the constant K, then of course plus C into T. The value of T is 3 millimeters. So this will be 3, then of course it is squared. So this will be 65 being equal to the constant K, then of course plus 3 squared, I'm going to get 9. So this will be 9C. So this will be my equation Roman 2. Then we are going to solve these equations simultaneously using either elimination or substitution method, so that we can get the value of our constants C and K. So let me use the elimination method because it's easier to work with in this setup of the question. So I'll write my second equation, which is 65 being equal to K, then of course plus 9C. Then I'll write my first equation, which was 40. 40 is equals to K, then of course plus 4C. So this is K plus 4C. So I'm going to separate, that is to subtract the two equations, because K will simply get eliminated. So 65 minus 40, I'm going to get 25. So I'm having 25 being equal to K minus K, I'll get 0. Then of course 9C, 9C minus 4C, I'm going to get 5C. So this will be plus 5C. So this means 25 is equals to 5C. Then I'll divide through by 5. I also divide through by 5. So that means the value of C will be equal to 25 divided by 5. I'm going to get 5 as the value of C. Then I'll substituting C is equals to 5. I'll substitute in the first equation. I'm going to get the following. So the first equation was 40. 40 is equals to K, then plus 4C. So if I substitute, I'll have 40 being equal to K, then of course plus 4, then into the value of C is actually 5. So that means 40 is equals to K, then of course plus 20. Then I'll separate my working using this line here. So I'm going to get the following. So this will be 40 minus 20 being equal to K. So that means my value of K is actually equal to 40 minus 20, which will actually give me 20. Now it means that the equation connecting that is M and T will be given by, so remember we had this equation here. Let me just rewrite it. M is equals to K, then of course plus CT squared. So if I substitute the constants that I've gotten, I'm going to have M being equal to K. My value of K is 20, then plus C. The value of C, we got it as 5. So this will be 5 T squared. So this is the equation connecting M and T. So if I've gotten the equation, remember they want me to determine the value of M when T is equals to 4 millimeters. So I'll simply substitute. M is equals to 20, then of course plus 5 into T when T is 4 millimeters. So this will be 4, but because it is T squared, this will be 4 squared. So this will give me 20, then of course plus 5 multiplied by 4 squared. I'm going to get 16. So this will be 20, then of course plus 5 multiplied by 16. I'm going to get 80. So that means that 20 plus 80, I'm going to get 100. Therefore, the value of M will be equal to 100. That is when the value of T is 4 millimeters. So thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that